Hey, AB Calculus, Mr. Ellinger here, and I'm recording this video on Sunday night. I've tabulated the results. This is my little spreadsheet to keep track of what the most popular votes were. And so we're going to go to it. I'll admit I've already recorded this video once, but then I had a problem with formatting it and uploading it to YouTube. We're trying a different browser to see if that works. So I already have the answers written up on the in OneNote. So you won't see me do them live, but I'll explain what I did. So sorry about that. I just don't want to have to re-record. All right, we're going to here. All right, and I got to switch back over to always true or not. So the most commonly requested always true or not was number 4. And number 4, the answer is no, that is not always true. I mean, you can find some ordered pairs where it's going to work. I guess if X and Y are the same number and neither one of them 0, then that works. But otherwise, I don't think anything else will work on this thing. And the problem is the plus. You can see I circled with great abandon the plus signs. The plus makes it so you can't cancel out. What did they do? They canceled out the 4xy and the 4xy, but they're adding on to other stuff. You could think of it, if you need a metaphor or something to stick in your head so you remember this, you could think of the plus sign or a minus sign as them kind of holding on to each other and saying, no, I won't go without you. And so you can't cancel one thing off that. I also gave an example. Sorry, I didn't erase to redo. I'll redo it here though. I gave the example. Come on, OneNote. Don't do this to me, OneNote. There we go. I wasn't emotionally ready for that. There we go. If I won $1,008 and it was going to be divided among 9 of us who bought tickets together and now we're splitting the proceeds, that doesn't mean I can cancel out the 8 and say that I win $1 million. $1,008,000 divided by 9 is not 1,000,000. And what you're doing by doing this is you're saying that adding on $8 more is equivalent to adding on 8 more people. And I think you can think about that and go, yeah, no, that's not a thing. The thing I showed was that if it was times, if it was like you won with an 8 multiplier and there were 8 people, then yeah, you can cancel out the 8s. That's totally fine. So, and then I gave one other example just to show it, like, of how this works, is that, like, suppose you have x squared minus y over x plus y. Can you cancel? Well, the only legal way you can do it is by factoring the top and then canceling out the factors. So you can cancel out the x plus y's and it becomes x minus y. And that's because you're canceling them out together. They're still holding hands. They go off to oblivion, and they're okay in oblivion together. Well, they're together at least in oblivion, and so the x plus y's could cancel out, and so you just get x minus y. So things multiplying each other, you can cancel. That's why factoring is so important in simplifying fractions. Things adding on to each other, you can't cancel one thing that's being added on to something else. Okay, next up is the meet the parents. The meet the parents one that I got asked about was number 15, and number 15 was this one, the greatest integer function. I'm gonna save myself some time, and I'll just say it's h, and I'll say we're not going to study this function in great detail. We might use it as an example of a discontinuous function. It's really helpful to illustrate certain ideas, but we're not going to run into functions like this very much at all. And it's not a required function that you have to know for the AP. But so anyway, but that was the most requested one. So 15 was h. It's called the greatest integer function, or the round down function is what I call it in my class, in my pre-cal class. And finally, we've got algebra, and I put it into the hints one because that way I already had the hints down, and that made it more possible. So you have to decide, and this was actually on the AP, and I've given this problem before to students, and they found it really tough. So if you were like, what the heck? Know that you have company. The AP has hard problems on it. Not all of them. Some of them are really basic and just, do you know your stuff? but then there'll be some hard ones, and you need to get resilient enough to be able to weather the hard ones, do your best on them, and move on. I'll let you know on the AP itself at the end of the year, when you actually go take the AP, generally a 70% on that gets you a 5, which gets you the maximum possible score. So you can see there's a pretty hefty curve. And so over the course of the year, you're going to run into some tests where there's going to be some difficult problems. You're going to get a question where the average in class was a 2 out of 9. But I look at how you did, how people did nationally, and how challenging the problem was. And I do curve things when they're AP problems. So just know that you're going to get hard problems, but we'll get you some support. And it's not the end of the world to have a really hard problem. Okay, let's answer the rest of these. So number 10 here, you need to know, when is this thing less than 0? And so we need to know, when does this thing get me a negative answer? It's a fraction. Could it be negative? Well, one thing to notice that's really helpful is that denominator always has to be positive, because it's something squared. It's something squared plus 1, so it's already positive, and then it gets squared again, just in case. And so that thing is really positive. It's just positive. You're either positive or you're not. And so if this fraction is negative, it's not because this is negative or 0. It's not because this is a problem, because this is just a positive number. So that means that if this whole thing is negative, that means the numerator has to be less than or equal to 0, because it says less than or equal to here. So I did a little algebra, did a little distributive property, combined like terms. I got kx squared, 1kx squared, and negative 2kx squared. So altogether that gets me a negative 1kx squared. And then I could factor out a k. So I need this thing to be less than or equal to 0. Well, and this is for all x between negative 1 and 1. Well, if you think about x being a number between negative 1 and 1, then this is always going to be either positive. The parentheses part is always going to be positive, or it could be 0 if x is 1 or negative 1. But we need this to be true for every number. And so, if x is 0.5, well, that's still going to be a positive number. So if this thing is going to be less than or equal to 0 for any x between negative 1 and 1, this part of it is positive. So that means k has to be less than 0, because the only way I'm going to multiply this times this and get a negative answer is if k is less than 0. You might have said, what if k is equal to 0? They said k can't be 0 up here, so you don't have to worry about that as a possibility. So I start off with a fraction less than 0. I could disregard the denominator because I knew that was positive, so that's not the issue. So that meant the numerator had to be less than or equal to 0, and I could factor it. Remember the factoring I mentioned earlier, and that meant that one of those had to be negative, but this one always had to be positive or 0. So the only way it was going to work was if k was less than 0. All right, tough problem. Yeah, totally tough. Number 14. So this is an example, just like number 13, where you have to graph. You have to graph the function to be able to solve the equation. 13, this was a cubic equation. It can't be solved algebraically with any tools that we have. And so you're supposed to use a graph to find out when the equation is true, because it's not solvable otherwise. And so you graph this. So you're like, well, not that one. Okay, well, same thing is true on this one. You end up with this equation. That equation isn't solvable algebraically. Students had to be able to do this on the AP. This was an actual AP problem. So how would I solve this thing? And remember, I have a calculator. We set it up above. And so I moved the 4 over. And so I need to solve 0 equals negative 6 plus y plus 5 cosine y. The only thing is I can't use my calculator if y is my independent variable. I need x to be my independent variable. So I just turn them into x's just for the purpose of solving the equation on the calculator. So I'm like, all right, I need to know when this is equal to 0 with the 4 moved over. All right, I'll find out when this is equal to 0, what x's make this equal to 0, and that'll solve my problem. So I graphed it. There we go. I graphed it and to put it all in there, got a graph. And then I want to find out, when does this thing give me an answer of 0? It asks for the smallest value, positive value. And so that would be right here. It looks like it's 5. It's not 5. It's close to 5, but it's not 5. So you go second calc and you hit a 0. You go to 0 because this will find the x-intercept. And it says, what number is too far to the left? That's too far to the left. What number is too far to the right? That number is too far to the right. I'm using the enter button to say, that's good. What number is about right? About there. There's the answer. It's x equals 4.928. So x is 4.928. So really that means y is 4.928. I was just using x temporarily because my calculator can't solve equations with y as the independent variable. So that was all you had to do to solve this one. Move it over, and then the little trick compared to 13 was that you had to switch it to x because you can't graph it otherwise. Finally, the last one is there's a line. Ooh, I got lots of time. There's a line passing through that point that has this slope. So I need to plug in 2 for x, and I need to plug in 4.928 because it's passing through the point, and the point they said was when x is 2, the y is 4.928. So therefore, when the x is 2, the y is 4.928. That's a point on the line. Now I need the slope of the line. Well, here's my formula. So I'll plug in the 2 and plug in the 4.928. I did that on the calculator also because this is a calculator question. And so I plugged in 2 for x and 4.928 for y. I made sure I was in radian mode. We'll always be in radian mode in this class. You'll never have to be in degree mode. So I made sure I was in radian mode, and it gave me this answer. And so that's the slope. The slope is 0.680. And then I wrote my answer in point slope. Y minus y1 equals m times x minus x1. You want to start doing this. The reason why is that's a perfectly legitimate answer and perfectly legal on the AP. So you notice I didn't like plug in the slope into y equals mx plus b and plug in the point and do algebra. I just plugged the numbers in and then I was done. You don't have to put it into slope intercept form. And so do it the easy way, which is definitely point slope form. You also could have done, since I have 2.5 minutes, wow. You could also have written it. I know one teacher who writes his point slope this way. They just move the y1 over to the other side. But I just write it this way. It's just faster. Y minus y1 equals m times x minus x1. And so that gives me the answer. So, 2 minutes left. So again, though, if you have other questions you want to ask me about, you can come by and see me. I'll be on campus for the next few days. You can email me. I'm posting this. I'm making sure the hints are in every content library. I won't distribute them. And I'll also get a link for this video that I'll upload to YouTube, and that way you can watch it and listen to my rambling repartee. Looking forward to the year. If you haven't done the survey, please do so. Even if you didn't get this stuff in, I still want to hear a little bit about you, and also just make sure I get preferred names right. And I don't know, if you have any questions, just let me know, and or stop by. And I'm around quite a bit over the next few days. All right, take care, and I'll see you either Thursday or Friday. Cheers.